So a black hole can be thought of as a single point. The event horizon of a black hole is the circumference of a circle centered on the black hole from which nothing, not even light, can escape. A spaceship leaving a space station will travel in the vicinity of the black hole with the trajectory s of x, and s of x is given, where x is greater or equal to 0. If the black hole is located at 1515 and the radius of its event horizon is 4√5, what is the closest approach of the spaceship to the black hole? Does the spaceship even survive? So the answer is given, but I'm going to tell you how to get to the answer. So some important information is the black hole can be thought of as a single point. So that means we're trying to find when the distance is closest to the black hole, right? So that means when this is closest to the single point is when the spaceship is closest to this black hole. And if it's in the radius, if it's in the circumference, then it is considered not survivable, like, because not even light can escape, right? So if it's in the event horizon, then it does not survive. But I'll just show you what that means in the graphs. You know, when it's given coordinates like these, it's a good sign to draw a graph to represent the question. So, sorry, to better visualize the question. So, oh my god, this is... Okay, so the black hole somewhere here, which is 1515, and the graph should look something like this. It doesn't matter how the graph looks like. It's just something like this, okay? It is something like this. It doesn't matter. It's just a placeholder graph. So say, the graph looks like, see, like this is the closest point, right, to the graph, x comma y, or in this case x comma s of x, where this is s of x, and this graph over here represents the trajectory. This point represents the black hole. So this and this represents the distance. This distance, right, can be represented as this, or a distance squared is equal to x squared plus y squared, and specifically the distance is equal to x squared plus y squared, and then whole root. That is specifically what the distance is, but this formula is also important. We can use this formula to explain why. So it's basically Pythagorean theorem, and it's not x squared plus y squared, it's actually change in x squared plus change in y squared, where change in x is equal to 15 minus x, and change in y is equal to 15 minus s of x. This. So okay, with this in mind, this is also change. So with this in mind, we're gonna try to optimize the distance to find the closest distance between the spaceship and the black hole. To do this, I need to have one variable in the distance, and to that we can plug in s of x into these values plugged in, and then I'll try optimizing it. I'm going to use this formula right here, because the cool thing about this is that a distance squared, the same values that require the distance to be the smallest, will be the same values that require the distance squared to be the smallest. So we can just optimize distance squared, and then we can find those values that allow the distance to be the smallest. I'll explain what I mean. So distance squared is equal to x squared plus y squared. But what is x squared? So 15 minus x squared plus y squared, which is 15 minus s of x. D squared is equal to 15 minus x squared plus 15 minus s of x, which is root 1 x plus 1 plus 15. 1x plus 1 minus 15. This 15 and this 15 cancel out conveniently, which leaves us with this. And a root squared is basically whatever's inside is left. So 15 minus x squared is plus ln x plus 1. Very convenient. And now we can find the derivative of this. So now we find the derivative of this and set it equal to 0, so to find the critical points for x. So I got two solutions. I got it in this form. I set it equal to 0, and to solve for x I put in the quadratic formula. I got two solutions, negative 0.9686, and then I got 14.9686, which I rounded it up to 15. And I'll explain why I rounded it up to 15 later. But this solution is extraneous because, as you can see, it says the domain has to be greater or equal to 0. And this is less than or equal to 0 since it's a negative number. So this is an extraneous solution. Now, with this 15, we have found x, so we need to find the distance from the black hole, right? The closest distance, so we'll plug it in into this distance formula right here to find the closest distance for the black hole. Okay, now that we got the distance from the black hole, the second question is asking, does it survive? So, if the distance is lower than the radius, if the distance to the black hole is less than the radius, then it does not survive because the spaceship is still in the event horizon in that scenario. And if it's in the event horizon, not even light can escape. So it does not survive. So let's see the radius. The radius is 4 root 5. So 4 root 5 is greater than 1.665. So no, doesn't survive because the distance is less than the radius. And the distance is equal to 1.665. Thank you.